Hey guys and girls, welcome back to another beautiful video on this beautiful channel, on this beautiful day. How you guys and girls doing? Today we're going to talk about insertion sort. Now this is a tricky one, a little bit tricky, well not really, if you're smart like me. No, I'm just joking. This isn't that hard to grasp, but the complexity it's still kind of slow. This is the average complexity, and the best case is obviously n if it's already sorted. So that's okay. It's a little faster when it comes to smaller tables, and it's a little better than the other algorithms we've been talking about, like selection sort and bubble sort and stuff like that. And it's a pretty good sorting algorithm to know if you wanna. You can actually use this in little smaller tables, but it's still kind of slow for bigger tables and things. We really don't want to use this for big databases and stuff. If you don't want to spend a lot of time sorting. So yeah, it's still good to know. Now to get started, what I'm gonna do is I'm gonna actually create an array with random numbers, but we're just gonna randomize it with the same seed. So that means we're gonna get the same random values every time we run it. So it makes it a little easier to calculate the execution time and stuff, which I also want to do. So you want to include time.h and iostream. Let's start out with the random initialization. So srand static cast unsigned 0. So this is the way to make a static seed, right? Just 0. And then I want to initialize the array. So this array is going to have a size, obviously. Const int array size equals let's start off with 10. Int array size, and we're gonna fill this array with a bunch of stuff. So array size, then we're gonna fill it. So array at position I equals random array size. So it's a good way to make random values. Then we're gonna make a test print just to try and print stuff. So a for loop, array size, and std cout array at position I, and a space, std cout, and a new line. So this is a test print we're gonna do in 2 spaces. So I'm just gonna copy paste this right here, and this is gonna be to show you the beginning of it and the result. And in between we're gonna have the insertion sorting. Alright, this is gonna be the insertion sort, but we'll get to that in a second. So for now we have the test print. Then we're gonna run the timer. So this is gonna be a timer for us. So int start equals clock, like that. And then we're gonna have a end for this timer. So int stop equals clock. Okay, and we're gonna do the test print and everything, and then we're gonna do a std exec time, so execution time, std cout time start minus stop. There you go. I think that's the way. We'll see how that works out. And a new line, ms, and a new line, like that. I'll do it like this, just to separate those two. So there you go. That's the execution time, and yeah, that should be fine. So if I run this, we shouldn't get anything special. We should just get 0 ms r2 to the array test prints, okay? Because we're not doing anything between start and stop. It's instantaneous almost. Sorry about all these dumb sounds. There you go. Okay, so let's get into the insertion sort. Now, what do we need for an insertion sort? Let's check out how it works. Now I have the GIF here. Let me just rerun this. So this is this beginning. This is an array. We begin with the first element. We put it in the sorted array section. We start off by taking the next element, checking it with everything in the sorted array. Like with the 3, we pick it, we put it up, we check it with everything in the sorted array, and we place it in the correct spot, and now it's part of the sorted array. Same thing with the 1, save it, check it with everything in here, find the correct spot, put it in the sorted array in the correct spot. Same thing with 8, but in 8 we see that it's already bigger than everything, so we don't do anything with it. 7, check it with everything, put it in the correct spot. So we check from this way. So as soon as we hit something it's smaller than, we put it to the left of it. Alright, so we're checking like this is going the wrong way, but we're checking from this side. And then we put it in where we need to. And the final element, we'll put it in where it belongs, which should be here. So that's how insertion sort works. Please just check out the wiki page for insertion sort. Check out this GIF, try to understand it, and try to play around with the code and you'll understand it better. But what we need is we need that position, 2 positions. We need one position which is the right outside the sorted array, the one we're using, the one we're checking with everything. So that is going to be called int sorted index. And we'll begin at 1 because the first 0th index of this array is already sorted, it's already there. We're going to start with a 1 to the right of it. And then we're going to, just like that, that's the sorted index right there. So that's now the sorted index. So we're going to add 1 to it each time we iterate. So we're going to make a while loop. The way this loop will end, the way we know that the array is sorted, down here, when it ends, it's all sorted. All the code for sorting is going to be in here. So the way we know is that sorted index is less than array size. As soon as it's the sorted index is the final index, we know that the array is done. We've gone through the whole array and we're done. So at this point 8 would be the sorted index and it's done. So that's how that works. So while it's smaller than array size, we'll keep going, we'll keep sorting. So there we go. And at the end of every iteration, every loop, we want to do sorted index plus plus. So we're kind of moving to the right in the array and adding stuff and checking that with everything else. Now, to start off, what do we need? Well, we need to find insertion index. We need to find the spot where we're going to put this value. So we have a value now with sorted index at 1, which would be some number for us, and we're gonna go through the whole sorted array and find a spot where we want to put this, and that will be the insertion index. Insertion index. And we'll put it to -1 because -1 signifies to us that we haven't found it yet. And at the end, after trying to compare it to everything, if we still haven't found it, we'll know that this is already sorted. There is nothing, this is smaller than. Alright, so that's how we're going to work. So then we need a for loop, and we're going to go through from 0 to not the whole size of the array, but to the size of the sorted array. And sorted index kind of keeps track of that. So sorted index is what we're going to go to. Okay, sorted index. And one optimization you can do here is and insertion index equals -1. So as soon as we change insertion index, that means we've found something and we'll stop looping. Okay, we'll go from the left to the right in this sorted array, find something. As soon as we find a spot, we'll stop looping, we'll save some overhead for the computer, stop working, we'll put it in there, and then we'll keep going into the next element. That's why we have this, to stop the loop. There you go. And the simplest way to do this is if array at position sorted index is less than array at position I, insertion index equals I. So we've found a spot to put this. And that's it. That's it. Now we've found a spot. Or not. But if we find a spot, so move everything in sorted in array if we found something. To check this, if insertion index is greater or equal to 0, because it can be equal to 0 as well, -1 is that you haven't found anything. 0 is still an index in the array, so we want to put the value at the 0th index. So that's valid, but yeah, as long as it's not -1. Now we'll check. Now we'll do this. We have to, if we look at this again, we are saving a value and then overriding that value. We're saving 4 in a separate variable. 4 is still here theoretically. 8 is overriding it. 7 is overriding 8. 6 is overriding 7. 5 is overriding 6, and so on and so on. And we put 4 where 5 used to be in that case. So for that, that's why we need to save the value. Saved value equals array at sorted index. So the value we want to check with everything, we have found a spot we want to put it, we're going to save it to a temporary variable here, and then we're going to move everything over. We're going to override what is to the right with what is to the left. So we need a reverse for loop, and this is kind of tricky. So we need to go I minus minus. I is greater than insertion index, and we start off at sorted index. Okay, so we're going from sorted index to insertion index. The thing we want to sort to where we found the spot we want to put it. All of that in between we're going to move to the right. So that might be a little tricky. Try to draw this up for yourself in your mind or on paper. Try to do this on paper as pseudocode and try to just do it on paper. Try to see how it looks in front of you. And this is exactly what we're doing as this GIF. So please check this GIF out as well. Please check the wiki page out and you'll understand it a little better. But okay, so we're going from the right to the left and moving everything to the right. And we have saved the value because this will be overridden now. All this thing does is array I equals array I minus 1. Okay, array I at the position I equals what is to the left of it. And then we'll move on one step to the left and do the same thing, one step to the left, do the same thing until we reach insertion index, which is where we want to put the thing. So now we have moved everything in the array. Now we're gonna insert value. This is move things. Inserting the value. So array at position insertion index equals saved value. Now we have put that value where we want to put it, and then we increase size of sorted array and go to next iteration. Whew. So this was a crazy coding session, but yeah, so this is one iteration. So we moved one thing and then we'll go on to the next and the next, and sorted index keeps track of how big the sorted array is. And if I run this, hopefully our array should be sorted, and yes it is. Look at that, 0, everything is sorted, and the time is shown down here. So stop is clock, we print that start minus stop, and we started the clock here as well. Okay, so what if we have 1,000 values? 1,000 values minus 1 millisecond. Okay, minus doesn't sound good, so I think it's stop minus start in that way. And this should be the time, the clock should be the time in milliseconds. I'm pretty sure it should be. Okay, so let's run this again with 1,000 elements. We'll get 1 millisecond, and everything seems to be sorted. I'm on debug. What if I run release? 0 milliseconds. All right, that's kind of funny. Divided by, let's see, clock. All right, cool. I think that's seconds, isn't it? I think that, no, it can't be seconds. It has to be milliseconds. I'm pretty sure. And what if we do, what if we give this a seed? So time null. Wait, you should do this. Wait, my bad. Time should be outside here. Time 0. So now we have random values. It's going to be completely weird. 1 millisecond. Run it again. 1 millisecond. And we're on release as well. If we run on debug, it should take a little more time. 1 millisecond. That's very interesting. 2 milliseconds. So I was up at 90 and stuff, but I'll check this out until the next video. But still, if we have 10 values and we run this, so we have a completely random array. Now we have a sorted array. Run this again. Let's see. There we go. Let me just run that one more time. Why is it full screen? Anyway, random array, completely sorted, no problems. So again, this is insertion sort. Go check out the wiki page for it with these beautiful GIFs, and you can actually see all of these nice GIFs, how this thing works. Okay, and here you have some more data about it and some more information and how you can like do stuff. All right, so check these out, and that should be good. So this should be insertion sort for you, and you should be happy. Everything worked out just as it should. If I'd made any errors, if this is wrong in some way and you're smarter than me, which you probably are, please tell me in the comment section and I'll try to fix it. But otherwise, thank you for watching. Best of luck to all of you. Take care and keep working hard, and I'll see you guys and girls in the next one. All right, bye bye.